Okay, here we go, taking our look at the calendar. Right up here, we are back on track. Class number 20 is today. We talk about derivatives of trig functions. Last class we reviewed the pre-calc side of trig functions. Coming up, we have a review of inverse function and log functions. That's again a pre-calculus day, followed by the derivatives of such functions. So we're kind of alternating between pre-calc review and then the derivatives of those pre-calc functions. Then we'll do like just one day of really complicated, as hard as they get derivatives, and then we have a review day for the test, and test number 2 will be here before you know it. It is on November the 3rd, which I think is a couple Mondays from now. Not this coming Monday, but the one after. Also coming up before you know it are the 2 projects. So on October 27, the drum project is due, so that's 5 days from now. I think that's Monday. And then coming up on Wednesday is the pipeline project. And I haven't projected these 2 projects at all, but I just wanted to pull up the timelines here real quick. So if you are following the suggested timeline on the drum project, then you are just about done by now. So if you like really are way up in the top of this table, or you have not entered this table, then you've got your work to do, and don't leave it until the day before it's due. I can say that in grading the first 2 projects, the arbitration and what was the other one? Trucks. The people that turned it in on time did much better than the people that turned it in a class or 2 late, and it's not because of the penalty for lateness, like taking out that penalty for lateness. I suspect the people that turned it in late didn't have an opportunity to spend as much time on it, didn't get to check their answers with their neighbors, and the grades suffered as a result. So you want to get this thing in on time, not just to avoid the lateness penalty, but to give yourself the best opportunity to work with each other. So you should be most of the way through the drum project, and here's the pipeline table. So hopefully, you know, sometime later today, you're getting something near 10, 11, and 12. That's the projected schedule anyway. Okay, so I'm not judging, like wherever you are, but this is where we are hoping you are, at least close to there. And if you aren't, then it means like you really got to get your butt in gear and get cracking on these 2 projects, okay? One other thing on this calendar was the quiz, so hopefully those quizzes are in the folders, right? Take-home quiz, so put it in the folder, and I'll give it back to you next time. Due on Friday. Okay, so let's jump in on page, what page did we say, 32? And we'll go up here to the top. Page 32, Ryan, the summary. Okay, so number 1, we've got a graph in front of us of y equals sine of x. We don't yet have a way to differentiate this function, but we're going to try to sketch the graph of its derivative. Now, I've told you this rule before just so we could use it, but we actually haven't seen that it's true yet. So let's see if we can start talking about what the graph of the derivative of sine of x looks like. So for me, if I'm graphing a derivative, I first start with the flat points. So where are the flat points on the sine function? Pi over 2, we've got a flat tangent line, and also a 3 pi over 2. So then what are the slopes of those tangent lines? 0. So then if I'm going to graph in green the derivative, then at pi over 2, I should be graphing a point at 0. So pi over 2 comma 0. So just say green is equal to the derivative of sine, whatever that graph turns out to be. And then at 3 pi over 2, we've also got a slope of 0. Let's go ahead and maybe estimate what the tangent line looks like at the origin. So is it uphill or downhill there? Uphill. So maybe something like that. We'll just make up a number for the slope of that line. Something about 1. If you say 2, that's fine. If you say half, I guess that's okay. We're just estimating. So let's, in green, let's say the slope maybe is 1. The slope of that red tangent line is 1. And let's go to pi. And the derivative, the tangent line at pi, uphill or downhill? Down, something like that. And it probably is like the same number that we had at the origin, but negative. So I guess we're saying maybe -1 is the slope of that tangent line. And then by the time we're back at 2 pi, then we're just repeating what we had at the origin, right? So maybe that's another slope of 1. And so I've got these 5 points on the graph of the derivative of sine, whatever that is. And I guess it's possible that if I connect these dots like it looks like that, but I don't think it does. I mean, it's kind of a smoother transition than that. And so we just try to connect those dots with something kind of curvy and not jumpy and not cornered. And lo and behold, we've drawn something that looks an awful lot like cosine. And it turns out that the derivative of sine of x is exactly cosine of x, which is absurd. Like I mean, this is one of the craziest results that I know of in Calc 1, is that the derivative of sine is exactly cosine. If you want the slope of one of these red tangent lines on the sine graph, all you do is find cosine of whatever x value you're talking about. And magically that gives you the derivative. It can't possibly be true, but it is. And it's not written here, but this gives us another opportunity to do chain rule things. So let's add this to the notes. The derivative of sine of stuff what's the derivative of sine of stuff? Cosine of stuff, right? It's just the regular derivative rule. So sine becomes cosine. So if it's cosine of the stuff, but then the chain rule comes in and says, hey, what do we need to do now? Let's multiply by derivative of the stuff. Okay, that's the chain rule. So do your normal rule, but then times the derivative of the stuff. Okay. Let's go down here to number 3, which gives us the graph of cosine. And much more quickly than we did above, let's see if we can plot a few points for the derivative of the cosine graph. So what's the slope of the tangent line at the beginning here? Maybe 0 at that flat one. And then like over here, maybe that next one has a slope of -1. And what's the next slope at pi? Maybe 0, and the next slope at 3 pi over 2. Maybe a 1, and then the last slope at 2 pi is a 0 again, and we're flat. And so if we just start plotting these points here, so the first one was a 0, and the next one was -1, and then a 0, and then a +1, and then finally a 0. And then we connect these 5 points with something smooth. And what does it look like? Looks like negative sine. Okay, so life was crazy that the derivative of sine is cosine. It doesn't work quite as nicely the other way. The derivative of cosine isn't just sine. Looks like it's upside down. So it turns out it's negative sine. So let's fill that in this blank here. Derivative of cosine is negative sine. And then we'll add another chain rule to our list. Derivative of cosine of stuff. See if you can write in this new derivative rule. Okay, what's the derivative of cosine of stuff? Negative sine of stuff. Derivative of stuff. Right, so it's like this same refrain over and over again, times the derivative of the stuff. Times the derivative of the stuff. That's what the chain rule says. Okay, now the pictures give a little bit of evidence that the derivative of sine is cosine and that the derivative of cosine is negative sine, but by no means is that a proof. You're going to actually prove that the derivative of sine is cosine in the activity for today. Okay, so there are 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent, and it turns out they each have a derivative. So we've kind of seen some evidence that that lead us to believe maybe the first 2 in this list are true. Turns out the derivative of tangent is secant squared. That is to say, secant x times secant x. That's what the derivative of tangent is. Derivative of secant is actually secant times tangent. Okay. And then going over here, there's actually some really nice analogs. Derivative of tangent is secant squared. Derivative of cotangent is cosecant squared, except negative. Secant goes to secant tangent. Cosecant goes to cosecant cotangent, except negative. So if you've got this chart written in this particular order, you'll notice that all 3 of these are negative. All 3 of these are positive, and that there's kind of like some analogous stuff happening in the 2 columns. So at some point you're going to memorize these derivatives. I guess sooner is better than later, because you don't want to have to keep referencing this chart over and over again. But with a little bit of practice, these derivatives will become second nature to you. So the activity starts on the next page. I would like to make a couple of these just a tiny bit more complicated than they already are. So can we update part B? Instead of this x right here in the tangent, I'm going to make it x to the 5th plus 3x. And then one more change down here in part C. Cross off the x inside of sine x, and we're going to make it sine e to the x. And then the x in the bottom on the cosine, we're going to make 4 to the x. And I'll walk around because now the answer key is no longer right because it doesn't reflect these changes. But I'll check the answers on this one as I walk around. Okay, get going.